All right, in today's lesson here, we're going to go ahead and do a proof of the cosine law here. So to prove the cosine law, we'll start off and draw ourselves a triangle. Label the triangle. So this will be vertex A, vertex B, vertex C. Directly across from angle A, put length of A, across from angle C, length of C, across from angle B, length of B. And what we're going to do here first is to prove the cosine law, I'm going to go ahead and drop down this altitude line from vertex A. That'll meet at 90 degrees here. And then what I'm going to do is I'm going to label this slice here as x, and therefore this will be a minus x, right? If the whole length here is denoted lowercase a, then this will be a minus x. So I'm going to go ahead and do Pythagorean theorem here. I'll label this with an h. So using Pythagorean theorem, if we kind of view this as two different triangles, a triangle on the left here is going to tell us that h squared plus x squared is b squared. And triangle 2 on the right is going to tell us that a squared plus a minus x squared is c squared. So we know these two pieces of information. Now, what we want to do here is make the observation that the cos of angle C is going to equal x over b. So therefore, I know that x is going to equal b cos of c. So I have this information here. Now, if we take a look at our two equations, I have a squared plus x squared is b squared. And I also have this relationship here. I'm going to isolate the h squareds and equate them. So therefore, just to give us some room here, I'll kind of put this information that we're going to use. I'll move it over here for now. We're going to come back to that result here. I'll come back to this result here. So I'm going to go ahead and I have h squared equals b squared minus x squared. And likewise, I have h squared equals c squared minus a minus x quantity squared. So therefore, I can equate these two, in which case I get b squared minus x squared is c squared minus a minus x squared. And we should expand this all out here. So if I go ahead and do that, I get c squared minus a squared. When I expand that out, I'm going to get a minus 2ax, distribute to be positive 2ax. And then lastly, this will be a positive x squared, and I distribute that, you get a minus x squared. So from here, we see the x squareds cancel. I get b squared equals c squared minus a squared plus 2ax. But as we just discussed here, we know that x is actually equal to b cos c. So I can get rid of that x and put b cos angle c. And therefore, to finish this off here, I'm going to isolate for c squared, in which case I get c squared equals a squared plus b squared minus 2ab to the cos of angle C, and that is our cosine law here. So I have c squared equals a squared plus b squared minus 2ab to the cos of angle C. Obviously, you can do this proof referencing a different altitude line. I used altitude line A. If you did the exact same thing with altitude line C and B, you'd get different variations on your cosine law proof, but they would all generate the same base cosine law. All right, thank you.